Hello everyone, and welcome to the lambda expressions lecture. So in this lecture we're going to be learning about lambda expressions, what they are, and how to use them. So we're going to start with a brief presentation, just describing lambda expressions purely in words, and then we'll learn how to do it in the live code session. So one of Python's most useful tools, and a lot of times it's really confusing for beginners, is the lambda expression. And what the lambda expressions basically allow us to do is create anonymous functions. So just quickly make ad hoc functions where you don't want to spend the time defining an entire function using a def statement. So what is lambda? Lambda's body is going to be just a single one-line expression. It's not going to be a block of statements. And the lambda's body looks really similar to what we put in a def's body return statement. So you can simply type the result as an expression instead of explicitly returning it. And then because it's limited to just like a one-line expression, it's going to be less general than a def function. So when are you going to use lambda? You can only squeeze design to limit program nesting. So the issue with lambda is that it's designed for coding simple functions. If you want a larger task to be done, you're going to have to use def. Okay, so the best way to learn how to use lambda expressions is to slowly convert a normal def function into a lambda expression. So let's go ahead and hop over to the code to see how that's done. Hey, okay, now we're at the lambda expressions Jupyter notebook, and I have it open here, and this is basically what we're going to all go through in a couple of examples during this lecture. So let's go ahead and get started. And what we're going to do is go ahead and jump to a live code session. So I'm going to make a really simple def function using just normal syntax. So I'm going to say def space. I'm going to name my function square. It's going to take in num as an argument. It's going to set a variable called result, square that number, and then it's going to return the result. So that's my simple function. It's just squaring numbers. So if I call it square 2, it releases 4. Okay, so let's go ahead and continue breaking this down, and you'll see that we're going to slowly form it into a lambda expression. So how can I keep reducing this function? If you notice, I'm returning result and setting result as a variable, but I actually don't need to do that. I could just return this nums to the power of 2, right? So I could just say return num to the power of 2, and that's going to be the same thing. I don't need to save this variable if I'm just going to return it. So let's go ahead and make sure that worked. So square, let's do 4 this time, and we get out 16. So that makes sense. Okay, so how can we put this all into one line? So Python, I know we've been making a big deal of white space for functions, but I could actually write this in one line in this fashion: def square num colon return num to the power of 2. Now this is kind of bad styling, but it is okay syntax wise to do that. Although I wouldn't recommend doing that normally, but we're doing that just to slowly convert it into a one-line lambda expression. So again, let's go ahead and do square of 3, and we get 9. So notice how in this format it still works. We have kind of this one-line function. So this kind of form is the form that a lambda expression is going to try to replicate. So when you're using lambda expressions, you're basically going to write kind of a one-line version of a function. And the way we would convert this square function into a lambda expression would look like this. I would type lambda num colon num to the power of 2. So the syntax is you write lambda, you write what it's going to take in, and then you write colon and what you want the output to look like. So this is one of the most basic versions of a lambda expression. And notice how when I run that, Python's going to treat it as a function. So I can actually get the function back by assigning a label to it. And as we've gone over a little bit throughout the course, we can actually assign labels to functions. So I could say square is equal to that lambda expression. And now if I call square, you'll notice it works just as it did for the full function. And just to make sure that it's actually taking its results from this lambda expression, let's go ahead and put square 2, put square 2 on 10, and notice you get the exact same thing. So that's the simplest breakdown of a lambda expression, and I'm just going to go over it one more time. You can think of a lambda expression as basically kind of this one-line condensed version of a function, where you have lambda, what you're taking in, and then what you want to do with it, separated by a colon. Now usually you actually don't save lambda expressions to a variable, since you want what's called a anonymous function, which means you never spend the time to actually save it. You usually run it within a context of your code where you just need something to quickly perform some sort of expression and then not worry about it later. So let's go ahead and go through a couple of more examples and really drive this lambda syntax into our head. So I'm going to say, let's make an example to check if a number is even using lambda expressions. So I would say lambda, I want to take in a number, num, and how do I check something is even? Remember, if the mod is equal to, the mod 2 is equal to 0, then you know it's even. So I'm going to say num mod 2 equal to 0. And there's my even function, or function to return a boolean, right? So I can set that equal to even, that lambda expression, and now I can check if numbers are even. So just like we did earlier, where we converted a function into a lambda expression, let's work backwards now and convert this lambda expression into a function just to drive the point home. So what is this lambda expression actually trying to do that a function would? Well, it would look something like this, right? Even, take num, return the boolean if num mod 2 is equal to 0. And that's going to be the exact same thing as that lambda expression. So you notice now, instead of writing this entire syntax of death, we can just actually have one-line lambda expressions throughout our code if we ever need just to do a quick function. Okay, let's go through a couple more examples. So let's say I wanted to make a function that grabs the first character of a string. So what would that look like? Well, I have lambda. I'm going to take in some s, some string, and I know the first character is just going to be the 0 index there, right? So again, I have my function. We can go ahead and save it if we want. Give it a variable. And now I'm going to say first of hello, and you notice it returns that 0 index. Okay, so let's move along. Let's see how we could reverse a string. We've seen this a couple times throughout the course. But remember, to reverse a string, you take it in, that s, and then you can actually just go through it backwards through indexing. Hopefully you remember this from your indexing lecture. There's our function. Let's go ahead and set it to a variable label called rev, and say rev hello. And you'll notice it's reversed. Okay, so moving on to a little more advanced, we can, just like a normal function, accept more than one argument into a lambda expression. So let's go ahead and see what that looks like. Let's say I wanted to add two numbers together as a function. So let's say I made a function, now this is just a normal DEF function, called adder. And it took x and y, and it returned the sum of them. So if I say adder, I could say add, let's say 10 and 12, we get 22 back. So now let's break down this function that takes in multiple arguments and turn it into a lambda expression. So I would say lambda, I'm going to take in two arguments, and you'll notice I separate them by commas just like I would in a normal function. And then what do I want to return? I want to return x plus y. And that's it. And then I could say call this adder. And now if I call adder in my code, you'll notice I can say 3030 and I get 60 out. So lambda expressions are really going to shine and be used a lot when they're used in conjunction with three main functions: map, filter, and reduce. And each of those functions actually has its own lecture, so feel free to explore them if you're more interested in lambda functions, but you'll be introduced to these three functions specifically since they have a lecture each. Okay, so there's a really great blog post that I highly recommend you read after you go through this lesson, and it's called it's at this site called Python Conquers the Universe, and it also has a great breakdown on lambda expressions and some more explanations for common confusion. So if you click that link in the Jupyter Notebook, it'll take you to this website right here, Python Conquers the Universe, and he says yet another lambda tutorial. There's actually a ton of tutorials out there for lambda, so you can check out his own links as well. But again, he goes over basically the necessities of what lambda is good for. And right now, you may not think that you'll be using lambda a lot instead of just writing a full def function. But you'll notice as you go throughout your code and don't need an entire function, you just need a quick expression, lambda will come in super useful. So as far as this blog post, he goes more into why you should use lambda and more of the theory behind lambda than actual coding. But I think it's a great blog post, and I highly recommend you read it after you go through this lesson and understand how to build your own lambda expressions. So let's go over quickly what we learned in this lecture. So we learned about lambda expressions, how they're pretty useful as anonymous functions and these ad hoc expressions. And we noticed that they're made of a single expressions. They're not a block of statements like you usually would for a full def function. So we have this def square function, and we slowly broke it down until we got a lambda expression that served a similar purpose. And then through our own lecture here in the live coding, we then created a lambda expression and kind of did the reverse, broke it back into, or built it back into a full function. And then we went through a couple of examples of lambda expressions. So just to reiterate, remember, a lambda expression takes the form lambda, some item or object, and then what you want to do to that item or object. So you could maybe check the length of it. And in context, usually you don't save, let's call this length check. You don't save a lambda expression to a variable like this. You use it in conjunction with map, filter, and reduce, which I know doesn't make a lot of sense right now since you're not familiar with these functions, but you'll see that when you're using it with map, filter, and reduce, you'll actually just end up passing this lambda expression as the argument instead of saving it to a variable. So now we can do length check. Let's say a string. How many cars does this string have? 37. Okay. So go ahead and make sure you understand at least how to read a lambda expression and how to build out simple lambda expressions. Don't worry too much about implementing these in your actual code. As you get more and more advanced in Python, you'll suddenly feel like, hey, maybe I can use a lambda expression here instead of writing this full function. Okay, so that's it for this lecture on lambda expressions. Hope you enjoyed it. Hope you got something useful out of it. And I'll see you at the next lecture. Okay, thanks everyone.